Okay, so today we're going to talk about horizontal transformations, and these are weird. I'm just going to be straight up honest with you. They are weird. They're a little difficult to understand. So we're going to write down, we're going to like look at a graph, and then we're going to write some notes down to kind of help us understand a little bit better why these changes are happening. Okay, so first of all, if I write this equation, if I look at this line, so if I start here and I move to there, all right, so I'm going to start here and move there. Now, I'm not moving vertically, I'm moving horizontally. So that means instead of moving up and down, I'm moving left and right. So all of the transformations we learned that are vertical, so we learned about the vertical stretch, the vertical compress, the vertical translation, and the reflection, all of those can also happen horizontally instead of vertically. Okay? So, but the equation looks different and it behaves differently. So first of all, if I just write the equation of this new line, before I even try to move it this way, I see that I have a rise over run that's 1 over 1, so that means my slope is 1. My y-intercept is 4. So the equation of this line is y equals x plus 4. All right? So this is x plus 4. Now I'm going to tell you that if we're talking about a horizontal change, we would also put x plus 4, but that horizontal change would happen inside parentheses. So the first thing I want you to write in your notes right now is that horizontal changes go from left to right along the x-axis, and they occur inside parentheses. Take a moment right now and write that down. Okay, so they occur inside the parentheses. So we've talked about, so we know that they're going to be going left to right, and they occur inside parentheses. So here's the thing. When I look at this, it seems wrong that x plus 4 is in parentheses, because I didn't go to plus 4, I went to minus 4. But clearly this is the line, it's the same line, I can't just change the equation. So let's kind of put that one in our pocket for a second. Let's put the fact that it's not acting, it's kind of acting the opposite of what we expect to see. Let's just kind of stick that one in the back of our head for a second, and let's look at this equation, and we'll see if we can make any patterns, okay? Now for this one, if I look at my slope, so if this time I'm going from here to here, I'm making that horizontal change, okay? Now, if I write the equation of the dotted line, my slope is rise 1, run 1, 1 over 1 is 1. My y-intercept is negative 4, all right? So I would write y equals x minus 4. And the horizontal version of this would be parentheses x minus 4. It makes sense for the vertical change because I'm going down 4, but I'm not going left 4, so it seems like it's opposite. It does the opposite of what I expect. And that is the next thing I want you to write down. When we have a horizontal change in an equation, the equation behaves the opposite of what we expect to see. When we're doing horizontal changes, it's like opposite day. If the equation says x minus 4, I would think I'd go left, but nope, I go right. If it says x plus 4, oh, I think I'm going to go right. No, no, I'm going to go left. Whatever it tells me to do, I do. Whatever I think I'm supposed to do, I do the opposite when I'm inside the parentheses. Okay? So I do the opposite when I'm inside the parentheses. Okay? Now, so let's think about what that means. Okay? So I've already seen that when the number inside the parentheses that I'm adding gets bigger, I go left. When it gets smaller, I go right. Okay? So if I'm horizontally moving right, then it's going to be like x minus a number. If I'm going left, it's going to be x plus a number. And that's exactly opposite of what I think is going to happen. Okay, that's not what I think should happen. Okay, and now my notes got a little crazy, so I'm gonna clear this, and you guys stay where you are. We're gonna fix something here because Miss Deal kind of lost her mind a little bit this is the second time I've made these notes. Boom, see, look, it's like nothing happened. It's like you can't even tell I did something wrong. Here, I'm going to make it even more like you so you can't tell. Look, I'm going to staple it in. Don't judge me. Or judge me, whatever. You know what? Whatever makes you happy. Okay, see, look. See? Notes are perfect. Nothing happened. Great. Okay, so now, so when I have my horizontal changes, okay, when I'm going right, it looks like I'm going left. So the equation is saying minus, which I think is going to go left, but it goes right. So what do you think is going to happen when I have a horizontal stretch? Okay. So when I have a horizontal stretch, if I have a vertical stretch, the value in front of x gets bigger. And again, that's outside the parentheses. But with a horizontal stretch, the number gets smaller. So let's call it the coefficient, gets smaller. So it will be like 1/2 x plus a number, or 1/2 x. Okay. So I would think this means it's getting flatter. Nope, because it's opposite times. Inside there is opposite town. Okay. And for a horizontal compress, the coefficient gets bigger. So it will be like 3x inside the parentheses. It's inside parentheses. This is only changes inside the parentheses. Okay. So and then a reflection. Still, my coefficient, it's negative inside the parentheses, but instead of flipping up and down, it flips side to side. Okay, and we don't really see this very much, and we really don't see a lot with the stretching, compress, and reflection. They really have you focused on this stuff, but we have to talk about it anyway. Okay, now, these, we don't see as many of these. What you might see is some of this crazy looking stuff. And that's when we have multiple changes happening at the same time. Okay, down here, multiple changes happening at the same time. Now, the best way for us to figure out what's going on with that is to look at point-slope form. Because remember, point-slope form is the form of a linear equation that has parentheses in it. So, let's say I have this equation, y minus 4 equals 3, x plus 1. Okay, I see one thing happening inside these parentheses. That means I'm having one horizontal change, and there's two other things happening. So in order for me to kind of be able to see what this change is, I need to just have a y on one side. So I'm going to add 4 to both sides. Now notice, I'm not going to add the 4 inside the parentheses because I have to deal with parentheses before I can add. So if I want to do that, I got to do something else. This zeroes out, and I have y equals 3 parentheses x plus 1 plus 4. Okay, so if I look at what's happening inside the parentheses, I have some kind of horizontal shift happening. Here, I have some kind of stretch or compress happening. Here, I've got a vertical shift happening. So these two are vertical because they're outside the parentheses. This one's horizontal because it's inside the parentheses. Okay, so let's look at this graph. This graph is that transformation. Let me write that equation down. So it's y equals 3 parentheses x plus 1 plus 4. Okay, so based on what we talked about just a minute ago, so we said this is a horizontal change, and these are outside the parentheses, so they're vertical changes. Okay, so when I look at that horizontal and vertical change, so first I'm going to look at my horizontal change. This says x plus 1. Anytime I add or subtract, I have a shift. So I have a translation. Well, it says x plus 1, so like that makes me think I'm going to go right. No, I'm going to go left. So I'm shifting left 1, okay? And it's because inside the parentheses it's opposite. But outside the parentheses nothing changes. So this says plus 4. That means I'm going vertically 4. That means I'm going to go up 4. So left 1, up 4, boom, I'm on the line. So I moved my vertex, I moved my origin left 1, up 4, and I'm on the new line. Now this tells me that I have a vertical translation, vertical stretch times 3. So that means I'm going to rise 3, run 1, rise 3, run 1 to build the rest of my line. Okay, this is weird. Let's try another one. Okay. If I just look at this equation and try to figure out what the change is, okay, first of all, I see that I have, to get to this point, I have to go down 3. So I'm going to just make a list, down 3, 1, 2, 3, 4, 5, 6, right 6. All right, so now if I look at my rise and run from that point, I rise 1, run 2, rise 1, run 2, and so that means I have a 1/2 slope. My slope is 1/2. okay? So my y, so if I write this, I have 1/2. Inside my parentheses, I look for my horizontal change. Right 6. That makes me think I'm going to go +6, but nope, it's opposite day. I'm going to go -6. I went down 3, so that looks exactly like it's supposed to be. And that's how I write that equation. You could also write it as y equals 1/2 x minus 6. And when you worked that out, it would end up being the same thing. You'd end up getting the same thing. It's not because this is a 6, it's because this is the y-intercept. Those are the same equation, okay? Let's do this last one. And again, this is crazy, but I promise you we're going to work on it. It's going to make more sense. Just kind of put this in your brain and let you think about it for a while. Okay, so let's think about this. If I go here, I had to go left 4, down 2. My slope is down 2 over 1, which means my slope is -2. So when I write my equation, I'm going to write y equals -2, parentheses. I went left 4, which looks like it's going to be -4, but it's actually going to be +4. I went down 2, so it's -2. All right. I know that's crazy. Just put it in your head. Watch it again if you have to. Write down questions and think about what you don't understand. All right. Have a great weekend.